Let's talk a little bit about exponential and logarithmic functions. I know that many students are quite nervous about logarithmic functions in particular, but there is just simply no way around them. So we have to learn the rules of the logarithm, in particular the natural logarithm. So in this video I will talk about exponential function a to the x, and then the exponential function e to the x, where e is Euler's number, the logarithmic function to a base a, which is written as log a of x, and then the natural logarithm, which is ln x. So the red circles here indicate two of the most important functions which appear not only in mathematics but also in science. An exponential function with a base a is the function a to the power of x. We do this only for parameters a which are positive. This function a to the x has several properties, and I'm sure you have seen them before. For example, a to the x plus y is a to the x times a to the y, or a to the x minus y is a to the x divided by a to the y. A to the x to the y is a to the x times y, and a times b to the x is a to the x times b to the x. I know reading these formulas is simply just boring, but you have to learn them. Try to memorize them, write them on a sheet of paper, post them to your wall, and look at them every now and then. So how do exponential functions look like? So they look like this. Y is 2 to the x in blue, y is e to the x in red, and y is 3 to the x in green. And why the heck do I all the time worry about this e? This function is really particular because it has a slope 1 at 0. So let's look here at the next picture. Here I show the function y is e to the x, and then the tangent line at 0 at the point 0, 1. And the slope of this tangent line is exactly 1. And this happens only for one value of this parameter a, and this particular value is called Euler's number, and it has a value of 2.71828, etc., etc. So it is an irrational number, so the decimals would never stop. But this number is important, and it is defined by the exponential function having slope exactly 1 at 0. Actually, tangent lines we learn much later in this course. A logarithmic function with a base a is the inverse. So it's the inverse of the exponential function with the base a. So we say log a of x is equal to y if and only if x is equal to a to the y. So logarithms are only defined for positive values of x. And the logarithm answers the question, what exponent y satisfies x is a to the y? That's what the logarithm does. And a particular logarithm is the inverse of the exponential function to the base e. So log ex is ln x. So we write ln for the natural logarithm. Properties here. Again, this is a 3 properties you should try really to remember. The best is tomorrow you practice them again, and in 2 days you practice them again, and in 4 days you know them by heart. So log a of x times y is log a of x plus log a of y. Log a of the ratio x divided by y is a difference, log x a minus log a y. And then log a x to the r is equal to r times log a x. Let's look at plots for the logarithm. So I show the exponential function to the base e and the inverse, which is the natural logarithm. And again, there are mirror images on the diagonal line. So the upper one is e to the x and the lower one is ln of x. Other logarithms to other bases are shown here on the right graph. Again, the natural logarithm is in red. The black line shows logarithm to the base 3, and the blue line is the log to the base 2. Important formula is a change of base formula. If you change from one base to another base, you can use this formula, which involves the natural logarithm. So log a of x is ln x divided by ln a. So let's prove this formula. Oh my dear, I'm allowed to do a proof. Yippee! Before I get all excited, let's get started. So I write y is equal to log a of x. This is what I would like to know. But then log a was defined to be the inverse of the exponential function. So this means this is equivalent as if I say x is equal to a to the y. But now I can apply the natural logarithm on both sides of this equation. So I write ln x is equal to ln a to the y. Now on the right hand side I can apply the third rule, which I had 2 slides earlier. So then this is also y times ln a. Now this equation I can then solve for y. So I get y is equal to ln x divided by ln a. But then y has really been this, right? So y is log a of x. So then putting this together, I have log a of x is equal to ln x divided by ln a. And that's the formula we have on top. So before I summarize, I would like to give you 2 examples just to practice a little bit the logarithm rules. And I do this on the natural logarithm because this is the most important one. So simplify 1/2 ln of 36 minus ln of 9. So a difference in logarithm is a logarithm of the ratio, right? So we keep the 1/2, but then this is ln of 36 divided by 9. That was one of the rules. Now 36 by 9 is equal to 4, so then we can write this as 1/2 ln 4. Now a product in front of the log is a log of the exponentiation inside, right? So this is log of 4 to the 1/2. But to the 1/2 is a square root, so maybe I just write this down here, square root 4, and square root of 4 is equal to 2. So then this is log 2. So what I simplified turned out to be logarithm of 2. Let's look at the other value. E to the log 6 minus log of e to the 6. Oh, I just noticed something which happens all the time. That people read ln, but they say log. So often, in particular instructors, they would say log and they would mean ln. I know it is confusing, but it is also very difficult to drive it out of people. The natural logarithm is just so important that this happens. So, do this again. E to the ln 6 minus ln e to the 6. So in the first, the ln is the inverse function of the exponentiation. So e to the ln 6 is just 6. So the first term is 6. For the minus term, we apply the rule that log of e to the 6 is 6 times log of e. 6 ln of e. Okay. This is then equal to 6 minus, now the ln of e, this is the exponent, so that e to the something is equal to e. Well, and this exponent is 1. So ln of e is equal to 1. Ln e is equal to 1. And so then here we get 6 minus 6, which is 0. So the term in front actually simplifies to be equal to 0. Let me summarize. It is important to memorize the rules for logs and exponentials, and the natural logarithm ln and the exponential function e to the x are the most important tools in mathematics.